EIGRP Layer 2 and Layer 3 MPLS design. When I first got into Cisco some 15 years ago, frame relay was the darling of the industry. It'd be rare to find a Cisco config example where you didn't have something about frame relay in there. Well, nowadays, frame relay has taken a back seat to multi-protocol label switching. It's still around, but MPLS is, what's new kid on the block everybody's running after. So before we get into the Layer 2 and Layer 3 design of MPLS, I want to give you a high-level view of what MPLS is all about. First off, MPLS is a service provider technology, as in the end customers don't usually participate directly anyway in MPLS. The way it works is as customers send in data to the service provider, which could be linking the customer sites together. Maybe we got a couple houses, right? Linked in there as well into this MPLS network. The data comes in and you've got all the header information, layer 4, layer 3 headers. And before you get to the layer 2 header, right, where you've got the next source and destination, we'll say MAC address or whatever layer 2 identifier is being used there, the service provider will squeeze in an MPLS label. One or more of them. So we can use multiple MPLS labels, and that does two things for us. One, improves routing speed. A lot of people have called MPLS a layer 2.5 technology, kind of between the layer 2 and layer 3, because essentially it keeps everything moving fast. It's very easy to cache. These routers actually exchange. They've got their own little LDP, label distribution protocol, where they tell each other what labels they're using. It's kind of a whole routing protocol in itself, but it keeps everything fast because it's down at layer 2. Now, the second thing that it does, let me actually add to number 1, that's good and all, but we've long since been improving router speed. For instance, things like Cisco Express Forwarding or Ceph has been caching the routing table, making it move faster. So if that was the only thing, MPLS wouldn't be as big a deal. The second thing is a big deal, and it is customer segmentation. Now, I would call that a little more of a Jeremyism, because I don't think you would see them say it that way in MPLS documentation. But essentially what you can do is represent an entire customer using one of these MPLS labels. So we can say all of the routes from, this, let's just say this is all one customer that I circled right there. All of those routes will be tagged with an MPLS label, we'll just say 50. And what that allows the routers to do is segment that customer's routing information from everything else at the service provider. Wow, that's really cool, because now we move into layer 2 and layer 3 MPLS. Using layer 2 MPLS, essentially all of these connections, and by the way, these can be whatever physical media you want. It could be an Ethernet connection bridged over fiber to that customer site. It could be a frame relay connection. It could be an ATM connection. It could be X25. It could be a straight to, it could be anything. Anything could end up going to that customer, but as soon as it gets in here, it's converted to an MPLS, which is kind of a independent protocol, apart from all of these other identification methods, right? And ends up bridging all of these customer sites together. Matter of fact, I've even seen cable and DSL MPLS connections, where you can connect somebody's house, maybe a home office or an off-site user, into the MPLS cloud over cable and DSL connectivity. Pretty cool stuff. So in a layer 2 MPLS method, it allows all of these guys to see each other over a layer 2 medium. Essentially, the cloud, the service provider, is presented to the customer as a big old switch, right, to where everybody has connectivity to each other. The layer 3 method of MPLS, it gets a little more interesting, because the service provider actually participates with you in your connectivity. Essentially, they make their routers available to you so that you can peer with them using a routing protocol. Now, the advantage of that is it gives you kind of a little more segmented feel, because, we're looking at, 4 different sites that are connected over this MPLS cloud. But imagine when this service provider, I should say this customer, ends up growing to 100 sites, 200 sites. Well, that layer 2 method just becomes unruly, because it's like 200 sites connected to a big old Ethernet switch in the sky. It just doesn't work. So using layer 3, essentially the service provider gives you the ability to peer with them. A lot of times it's using BGP, but you can also use protocols like EIGRP, like we're talking about right here, to form neighbor relationships, and essentially their routing table becomes your routing table, or vice versa, to where you now see them as a peer, a neighbor, exchange routes with them, and then using those MPLS tags, they keep your routing table separate from all the other customers' routing table in the cloud, to where you essentially get your own little personal router in the sky. With that foundation, we can talk about layer 2 and layer 3 MPLS design. First off, if you're going layer 2, that again means that all these routers will see each other connected to that cloud as if this was a big switch. They will all form neighbor relationships with each other through that cloud. So, as a Jeremy rule of thumb, you won't see this on a certification exam or something like that, but somewhere between 10 to 20 routers, and 20 is really stretching it, this just becomes unruly. Not just from a resource consumption because you're having to maintain all these neighbor relationships, but also just from a design perspective. It just gets muddy sitting here in the middle of this giant blob of neighbor relationships in the sky, if you will. Now, you could actually use VLANs to separate this out. Let's just say you have Ethernet terminating over here. You could actually connect a switch in front of that to where you take these VLANs and actually tag them to where I set up a VLAN between these guys and a VLAN between these guys to where they can form different neighbor relationships on, for instance, different sub-interfaces. Think of like a router on a stick. So we would create VLAN 100, which maybe would represent the connection between this house and this corporate office up here, set up its own little point-to-point network over that. Yeah, you could do that. But again, it just starts getting unruly. Even around 10 to 20 neighbors, it just makes you feel a little better because it's kind of segmented to where you're like, oh, it's kind of like a bunch of point-to-point WANs, right? So instead of that, layer 3 design is typically the best way to go. Now, usually, I'll say, and I'm talking real world experience, usually the service provider will much prefer to use BGP here rather than EIGRP. Why? Because BGP is what they're going to be using internally. That's what they actually do. Once they receive all your routes, they'll take EIGRP or OSPF or whatever routing protocol you're using here and actually redistribute it into BGP because that's what works with MPLS very well because it kind of integrates with the tags to send the routes between all the routers in their network. So of course the service provider is going to say, hey, you know what? Why don't we just run BGP natively between these so we don't even have to do a lot of the redistribution and work to make that happen. Now, that being said, you go to these home routers, a lot of them aren't going to have the capability to run BGP because that's usually an enterprise protocol and a whole different level of understanding to set that thing up. So if you push, you can get them to run EIGRP sometimes, and almost all the time OSPF between you and them. That, I would say, honestly, if I were running this network, once I started reaching around 8, maybe 12 routers, I would start saying, okay, this layer 2 thing kind of needs to go over to layer 3. Now, the other thing that you get with layer 3, and I'll say some service providers do it at layer 2, but most of them will always do it at layer 3, is the option to start enabling QoS. Meaning, once the routers are starting to participate with you, you then can communicate with them a little better in terms of attaching different tags to your traffic. So you can say, well, I'm sending voice over IP over this MPLS network, and I want to make sure that gets prioritized over all the other stuff, or different levels of priority. Like I've got some database replication happening, or whatever you've got going. You can prioritize those different types of traffic using layer 3 MPLS over the other types of traffic that exists. So this nugget's a little bit of a bonus. You got to get an MPLS overview and see the EIGRP layer 2 and layer 3 design. I hope this has been informative for you, and I'd like to thank you for viewing.